The topic of this presentation is the plant nutrient potassium and its importance in turfgrass growth and development. Potassium is one of the 16 essential elements required for turfgrass growth. Of the 13 essential mineral elements, potassium is second only to nitrogen in the amount required to sustain turfgrass growth. As shown in this figure, potassium comprises 1 to 3% of shoot tissue by weight, compared to nitrogen, which is at 3 to 5%. The analysis of potassium, along with nitrogen and phosphorus, is displayed on the front of fertilizer bags. The potassium is expressed in the form potassium oxide, which is the standard form that the American Association of Plant Food Control officials use to set what the fertilizer manufacturers must guarantee in their fertilizer products. In this case, 8% of the bag contains potassium oxide. The actual potassium in the bag is 83% of the potassium oxide. To calculate the amount of actual potassium using the previous fertilizer bag analysis, the potassium oxide content in the bag is 8%. If you multiply the 8% times the weight of the bag, which is 50 pounds, you get 4 pounds of potassium oxide. By multiplying the potassium oxide by the correction factor of 83%, or the decimal expression of 0.83, the amount of actual potassium in the bag is 3.3 pounds of potassium. Potassium, when it's taken up by the plant, is highly mobile within the plant. Although a major nutrient, potassium growth responses are not observable. Potassium does not influence growth per se, nor enhance color. Nitrogen, in contrast, induces a color and growth response on the turf, shown here by the nitrogen application stripes across the screen. Potassium is not found in any plant compound, but it is required for the activation of many enzymes. Potassium is also a cation that remains in the same form. As previously mentioned, potassium plays an important role in enzyme activation. Enzymes are proteins that catalyze reactions important in plant development. Without potassium, these reactions, like protein, sugar, and starch synthesis, are greatly reduced or cease entirely. Potassium plays also an important role in plant-water relations. Starch synthesis, or starch accumulation, which is the storage of energy, is important in warm season turf grasses, especially during the fall. It is the starch that helps provide the necessary energy for Bermuda grass during the winter. When these starch levels are low, the ability to survive winter injury, as shown here, is less likely. In a study done here at The Ohio State University by Dr. John Street, he looked at various rates of potassium on Bermuda grass winter survival. Bermuda grass is not adapted to Columbus, Ohio, but Dr. Street found a higher percentage of Bermuda grass survived winter as the rate of potassium increased. Potassium is not only important for winter injury survival in warm season turf grasses, but other stresses like temperature, both high and low. In this case, this photograph is freeze injury on annual or annual bluegrass green, which is a cool season turf grass, but again, potassium plays a role in carbohydrate formation. Potassium is also important in drought or moisture stress survival, and helping to reduce wear injury. Traffic or wear injury can be seen here from golfers crossing the walk bridge. If potassium deficiencies do occur, the lack of potassium can adversely affect water relations and stomata regulation. Regarding stomata regulation, potassium plays a role in turgor pressure, which influences the opening and closing of stomata. The photograph here shows stomata on a tall fescue leaf. In potassium deficient situations, stomata tend to remain open, resulting in increased water loss through transpiration. Potassium deficiency symptoms on leaves appear as interveinal yellowing of the older leaves, followed by a dieback from the tip. Eventually the leaves become yellow. Other less quantifiable but no less observable traits include a greater tendency of the turf to wilt and suffer wear injury. Potassium deficiencies are most likely to occur in areas of high rainfall, on sandy soils where the potential for leaching is high, also on low pH soils, and where high rates of nitrogen are applied. Due to the characteristics of a high sand content root zone, which includes a low cation exchange capacity and high leaching potential, potassium cannot, or is it extremely difficult to build this nutrient up in the soil. Thus, light frequent applications of potassium on high sand content greens would be recommended. In developing a potassium fertilization program, the first step is to determine the soil potassium levels through soil testing. Testing should be done on a regular basis. Testing is fundamental because how can one determine the proper amount of a nutrient to apply without first knowing how much is there? If soil deficiencies are present, these deficiencies should be addressed and corrected. Routine or maintenance applications of potassium, especially on highly maintained putting greens, should be made frequently through the season, especially during the summer stress periods. How much potassium needs to be applied is usually in relationship to the amount of nitrogen applied. In most situations, including putting greens, a ratio of 1:1 or 1 to 1.5 nitrogen to potassium is sufficient. If the amount of nitrogen applied to the turf is extremely low, the ratio may reach 1 to 2. No benefit has been observed or reported with ratios exceeding 1 to 2. This concludes this presentation.